frames of reference. All we had here, let me just start out by saying that the Secret Service was established as a law enforcement agency in 1865, and while most people associate the Secret Service with presidential protection, its original mandate was to investigate the counterfeiting of U.S. currency. And so if you're going to teach somebody to be really, really good at spotting counterfeit currency, what do you need to do? Do they need to study counterfeit currency? Did he get a sheet? Did he get a note sheet? There's one. Did you have enough?
I have Foggy reference, or Foggy character.
That's frames of reference is what it is. Yeah. All right, there you go.
You got another.
Yeah.
Fill both out.
Yeah. All right. So anyway, would you study bad funny money, so to recognize it? Or you recognize it?
No,
They study good money, and they look at it really, really good, and they get to where they know it one inside out, and then as soon as they see something wrong, they know right away know. That's the same way it is if you plug a scan tool into a bunch of good cars and all that. You got that scan tool unplugged and put away, didn't you? Okay. If you plug a scan tool into a whole bunch of good cars, and you're looking at them, you're always looking at them. Make sure, and that was in that little handout I gave you that the other day, that little 2-page handout about scan tools. If you can recognize the good cars and automatic transmissions, one of the rules of thumb is if you want to get good at recognizing transmission pressure issues, put a pressure gauge on your car and drive it around for a week and watch what that pressure does every time it shifts gears, and you'll know it really well. And you'll understand when you put one on that's not doing what it's supposed to, what the problem is. Now, when I first specialized in drivability and electronics in January 1986 at the Ford place, I was working on cars that were, well, fuel injection started out in 1980 on Ford. What's the earliest car you can think of that was mass production had fuel injection on it, electronic fuel injection? What do you think of?
I mean, I know I could say my truck, but that's not really considered.
When was it? When did fuel injection first become prevalent on a car that was sold lots of copies? 1968 was the first one I knew about, and it was on the Volkswagen Squareback. It had electronic fuel injection. It was Bosch, and you could buy just about anything you needed to rebuild that engine controller from Radio Shack. Pretty cool little deal. But anyway, but older people that are familiar with Ford stuff know that, well, like on this Mustang out here, Ford didn't have data stream capability till '88. Then it was only on Lincoln, and I'd gone to Ford training, and it had been handed this huge book we call the H manual. It was about that thick. And you know, whenever you go to school, they teach you these little canned procedures, and you come out of there feeling like you're going to change the world. Well, I got back to the shop over there, and I started trying to fix cars by going through that book, and they had these little trouble trees in there and stuff for it. Well, it's basically, it was you know, they'd ask you a question, they'd say yes or no. If the answer was yes, you went to this box. If it was no, you went to another box. And for about 2 weeks, I fought with that thing, and that stupid book didn't take me nowhere. And I put it back on the shelf, and I just started measuring voltages. Because the cars that we were working on back then didn't have any data stream. You could just plug in and go in and look at fuel trims and all that kind of stuff on the cars I was working on. So I had to back probe all of the, what I did was I back probed every sensor on every car that came in there, and it was amazing how fast I got to where I could recognize what was wrong. And so somebody come a car in there and it was given a particular problem, I'd measure the voltage, I'd say that's not right, put a sensor on there, remeasure the voltage, take care of it. I put the car out there in 15 minutes. Be through, and I was working on 12, 15 cars a day. I was knocking out bam, 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 like a machine gun, because I got to where I was pretty doggone good at fixing those cars. Something wasn't running like it should. If it had a sluggish oxygen sensor, I'd pop one of those on there right away. But when I found out what the numbers were supposed to be, I could troubleshoot just about anything on EEC4. Well, I gathered good numbers on good cars. I got my own private frame of reference. Now, you're going to look in your book sometimes, you'll see what the voltages are supposed to be. It'll be like a window. Should be between this and this. That's kind of like your mode 6. Mode 6 has got the computer looking at every little monitor that it's looking at, and it's looking for values that are supposed to be between this and this. It'll tell you what the unit is, and if it's outside that unit or close to the edge, that's for an early warning failure thing. Now, we don't have any idea what the fuel trim numbers are measuring live unless we're plugged in with a scan tool. The old pre-J 1930 regulation, some of them had data stream, like Chrysler and GM had data stream, and the short fuel trim was called integrator, and the long fuel trim was called block learn. Remember that. If you ever see that, now you'll know what it is. Integrator was short fuel trim, block learn was long fuel trim, and it was between a 0 and 255 basic 8-bit binary scale with a 128 as a 0 point. For closed loop fuel control, we can usually watch a healthy set of oxygen sensors, how they're performing to determine if it's a closed loop. But it's a lot easier just to watch the PID on a liquid crystal screen, plug it in, pull it up and see what you got. Now what's wrong with that is that if you run into one that won't start and won't talk, or if it, if there's something wrong and it won't talk to your scan tool, you're sort of sunk if you're not used to that. Well, this particular PT Cruiser had been one, we put a timing belt on it in 2006 when it had about 120,000 miles on it. And the owner decided it was time to have it done again because she put a lot of miles on it. So she took it to a little local garage, and when the job was done, it ran fine for a few miles, but then it started bucking and jerking. Boom, 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 boom. And the problem was worse when it was hot. So she took it back, and he found a P1391 code. And I'm going to go ahead and move to this next slide here. That's the code that we had showing up on that thing. We had a P1391, and in any case the loss of the cam and crank signals, the cam sensor was replaced at that shop, and it draws its signal from the end of the camshaft. Didn't do any good. A trip to the local dealer produced a $1,000 estimate that included replacing the engine controller. They're just going to put a computer on it, whatever, throw a computer at it, see if that takes care of it. They rejected that dealership estimate, but she bought a used engine controller from an online supplier and had the original garage put it on there, but the PT wouldn't even start with that controller plugged in. Probably had, vehicle theft protection on it or something. Hers didn't have it. Anyway, she brought it to us, and I let her take me on a test drive so I could see what was going on. A lot of times when somebody brings one to you, it's a good idea to let them take you on a test drive so they can show you what they're talking about, particularly if you're working on a noise. Because you might work for 2.5 hours on a noise that ain't even what they were talking about. And then when they come back and they ride it again with you, they say, it's still making the same noise. You say, well, I fixed that rattle over on the left side. They said, oh, I knew that. I didn't know what I was talking about. I was talking about this bump over here that was on this other side. And I don't want to pay you for fixing something I wasn't complaining about. Make sure that you know what they're talking about before you start. So she took me over here. She duplicated the concern. It was a violent symptom that was common on all the cylinders. Like what I want to know, if I got something acting up, is it something that's common to all the cylinders, or is it one cylinder dropping out? If it's common to all the cylinders, it'll feel like you lost the whole engine and then got it back. If it's missing on one cylinder, it'll go tit-tit-tit-tit-tit, it'll this kind of thing, like a machine gun or something. Well, there didn't seem to be any rhyme or reason, except to her the problem seemed worse when the engine was good and hot, and she'd either just made a turn or was straining to go up a hill. And her mechanic had double-checked the timing belt. Seemed to him like everything was okay. All right, so we went on to this next thing here. We got this, these PIDs here kept showing up here. Crank signal, yes. Current sync, lost. We're getting this kind of stuff, and that was a crazy thing. We went ahead and looked at the crank sensor, and we, looking down there, nobody had touched the crank sensor. You can look at the crank sensor on the thing, tell nobody's touched it at all. Now, it does look like it leaks some oil around it, doesn't it? If on that picture right there.
Oh, it's crusty looking.
Huh?
It's crusty looking.
Yeah, it looks pretty nasty. You could tell if somebody's had their fingers on it, though. Nobody had even had this one unplugged. It's on the back of the engine block. You got to raise the motor up on the lift to get to it. It's aggravating to get to. But once it's up on the lift, it's not. But from the top, you just about won't get to it on that PT Cruiser. But we pulled the sensor out. And when we pulled the sensor out, we saw we had oil all puddled up in there around the terminals. That ain't good. If you see oil puddled up around the terminals, get rid of the sensor, put another one on there. Whatever happens, it's not good to have that in it. It ain't really good to have greasy connectors with oil all over them and that kind of thing. Sometimes it causes more trouble than others, but if you're having a problem, if that's a suspect on, don't put a sensor back in there that looks all greasy and cruddy like that, and think everything's going to be all right. They make some electrical contact cleaner that you can spray up in there and wash the oil off of the female connectors, and you put that back on there, and you get that. So we noticed while I was holding the throttle in the service bay that the bucking and jerking would happen sometimes even when it wasn't under load, if I was just holding it like in park or neutral. It had stored the P1391 along with the P0340 and a 320, all related to cam and crank signals, and we saw the new cam sensor the other shop had put on there, but the crank sensor hadn't been touched, so we went ahead and put one of those on there. So we hooked the timing light up to check for spark dropout. You ever do that?
Spark dropout?
Yeah, me and Bert were driving a car one time that was kind of like our Oldsmobile out here, and we drove it, and we actually found a bunch of other stuff wrong with it. That was as a matter of fact, the car was so old that most shops wouldn't even want to work on it, and I don't usually work on anything older than about a 92 here, but this one here belonged to a lady that I went to church with eons ago, and she qualified to have work done for one reason or another. Anyway, we got in there checking this thing. It was a strange deal. It was a Oldsmobile Cutlass, 85 model, had a V6 in it, and it was idling really, really rough and acted like it had EGR issues. And of course, it had a bad tire on it, a big old bubble on it, and all that. We had to fix that. And the cam sensor, when we hooked the scope up to it, the cam sensor wasn't putting nothing out. So we put a cam sensor in it, got a cam signal. It ran better, and then we were driving it down the road. It ran pretty good, but every now and then it would buck and jump and cut up, like it had some kind of ignition problem. So I got a timing light, and I hooked it up to one of the spark plug wires, and I just dragged it in because it had even back in 1985 and 86, GM on some of their cars had coil packs. And I hooked it up to that timing light, and I fixed it where the trigger was pulled all the time, where it was always flashing, right? So I had it in the floorboard, hooked up so it was always flashing, and when we'd drive that thing, we'd watch that timing light. And when this problem would happen, that timing light would quit flashing for a second, and then we'd come back. So we were losing our spark. What we wound up doing on that was putting a module on it, which the module was underneath that, all three of them, coil packs. Except I think that was the Magnavox module that was all made together. One way or another, we connected the timing light to see if the spark was dropping out, and we put a fuel pressure gauge on it, and we drove it again, and it seemed to run better, but eventually it bucked and jerked, and this time it stalled while we were entering the service bay. The tachometer needle was bouncing around all over the place when it did it, and that happens sometimes in no-load situations too, but during no starts, the fuel pressure was good and strong at 56 PSI. Sometimes it wouldn't start. And the injectors were clicking. The timing light we connected from our test drive showed that a good even spark was pulsing. This whole thing was just really getting complicated. You know what I mean? So after a really brief period of time, it would usually start and sometimes ran just fine for a while afterward. But we were losing our spark. See, Identifix search spoke of cam gear pin locator pin problems causing an index to turn between the gears. Like there's a pin that keeps the cam gear positioned right with the camshaft. And if somebody puts it on there wrong and they push that pin back, you may have a camshaft where you have timing marks maybe lined up, but your camshaft may be out of time. And that'll throw you 3 or 40, and it'll cause you to have cam and crank out of time with one another. And I'm giving you a really, really good handout next week. That's another one of those pending pop test deals that's talking about, cam and crank and how these things read and all that, how some of the sensors work. It's really, really a good thing. But it ran just fine before the timing belt job, so we said, well, maybe there's a problem related to the indexing of the gear. You got to dig as deep as you can. We're searching for the truth here. So we hooked up the scope to the cam and crank signal wires, got a strange looking pattern with, that I didn't like, so I used a different scope. But there was consistent on-off signals on the cam and crank that I never saw go away while I was checking it, but I really never saw the problem anyway. So I got this, when I put the other scope on it, and what I wound up with, the intake camshaft was running slightly behind where it should according to what our pattern was looking like. So we, pulled the upper intake, part of the timing cover, and we made sure, brought them around so the marks were lined up, and everything was fine. I couldn't get them to turn, separately for the gear and the camshaft and all that. So we're back to square one. Had to rethink everything. Every now and then when you're troubleshooting one, you'll be back at square one, and you got to rethink everything. And that's where we were. 80% of the time it ran good. There was absence of any movement between the cam and the crankshaft and its gear. I started moving in a different direction. Let's put the scope pattern aside and let's go back to the basics. So I started to approach it like I was seeing it for the first time. Incidentally, this is the pattern. This is what the pattern, incidentally, is supposed to look like on that particular thing. This is what everything's doing during this pattern. Now down here at the bottom, you're going to see the cam signal. And you got a 210 degree window there, 150 degree window there, another 150 degree window there, and it goes back to a 210 degree. All right, then you got these right here. The flywheel's got those sets of 4 holes in it. And this is what it's supposed to look like. All right, let's look a little closer at that. See that? That's what I was basically looking at with my tool. All right, look at that and see how it looks. Right? The comparison engineering schematic. Watch this. This is what we were seeing on our scan tool. See, there's your 150. There's your 210, there's your 150, and see where that is? Right there. All right, look where it's at. Now we'll back up. See where it's supposed to be. See, this is a top dead center 4, top dead center 2, top dead center 1, and top dead center 3. All right, on that one right there, you see how that looks slightly different than what it's supposed to? Your first 210 up cut is where? It's over here. All right, but if you draw these, I drew this yellow line so it can line up. It looks like everything's a little out of line if you compare that to that, right? So you're supposed to be like halfway, you know, right, just past halfway on that, just past halfway on that, and then it goes back the other way. And so I got so bogged down in that scope pattern that I was, you know, looking for this. You can overthink this thing. Unlike Jonathan came in there this morning and picked up a coffee stirrer and thought it was some high-tech part of a wire harness or something. That was pretty cool. All right. Never seen anything that funny lately. So I back up over here, and I was looking at the routing of the harness to see if it's making its way across a sharp edge. You know what I mean? One time this guy brought a van to me. He said, I've had my van all over town, and it's bucking and jumping and cutting up, and I've spent, he said, I didn't want to come to the Ford place because I figured I'd get charged too much money, so I went to this shop and this one and that one and the other one. All of them charged me a little money and put sensors on it, and now I got $725 in it, and it's still just like it was. And they ain't none of them wanting to help me fix it. And I said, well, let me just walk out here and have a look at it. So I walked out here and had a look at it, and I pulled the doghouse off of that. It was a van, and I pulled the doghouse off of it, and there's a wire harness dragging across an engine hoist bracket, and you could see copper, you know, where it was scratching. So I pulled that back and fixed those wires, taped it all up, and charged him 20. Huh?
It was grounding out.
Yeah, grounded out. The wire harness was grounded out. Everybody's missing that. But I mean, I just basically did a visual inspection and saw it, taped it up, and you know, I was pretty well in charge of how much they charged the people that I was working for. And I told him to put $20 down on his bill, so he paid his $20 and drove away with his van fixed. He says, I know where I'm going to go next time, you know. Of course, you know, a lot of the times when you go somewhere, if they're hiring OJT people, a lot of the times they're hiring people that hadn't had any training and hadn't been taught how to troubleshoot. And they're just sort of like the guy that was putting the $1,400 engine controller on that, I was telling you about, and the rats had chewed the harness and all that stuff. You don't like that either. Well, with the engine running and hot and the thing in the air, I fooled with, well, before I went in the air, I disturbed the cam sensor, and I didn't do anything that way. But when I finally raised it up, what I finally did was I grabbed a hold of the crank sensor connector, and I wiggled it while the engine was running, and it stalled. And every time I jiggle that connector a little bit, it would stall. Well, when the engine's taking off, it's torquing, right? And the crank and the wires coming to that sensor were, you know, bending a little bit, and it was making it cut off. And the whole thing, all this scope business and everything, you know, and the guy that had worked on it apparently over there hadn't done anything with the crank sensor because it was hard to get to. You couldn't look at it and tell there was anything wrong with it. You couldn't unplug it and tell anything was wrong with it. But when you move those wires, it would break. I got a pigtail for it from the parts house, and you could get one. And I put it on there, soldered it, taped it up and everything, and then we wound up with it. It was an old-fashioned wiggle test. That's what you call a wiggle test. You watch for something to change while you're jiggling the harness at a particular spot, right?
That blower motor, that's how it is.
Yeah, he did a wiggle test on that thing.
Hey, does it work on all the speeds now?
When I fixed the blower motor resistor,
Yeah.
I scraped it up, cleaned it up, and I checked it, and it works through all of them. Even the off works.
He had to go in there and tweak on that. He managed to spend most of the day working on his own vehicle again yesterday, so that's okay though. He's all right.
Not most of it. Me about like
Yeah.
85%.
All right. So what did you get from this? You're gonna a lot of the times you just need to think about simple stuff. Now the scope pattern, I'm gonna say one more thing about scope pattern on the cam and crank sensor. I had an Altima in here one time, and this doggone thing had a cam sensor put on it somewhere up the country on the way back down here from whatever. And this cam sensor is a digital cam sensor. I got one out there that I can show you guys. I can hook up voltage to it, and it basically puts out a 10-volt square wave. And I had the pattern of what it was supposed to look like, and that darn thing was totally out of line. Now on that one, that particular Altima's got a timing chain, and nobody had been there, and the timing chain don't jump as long as these sliders are where they're supposed to be. And I said, I know this thing's not out of time. I know absolutely for sure it's not out of time, but the scope pattern indicates that it is. All right, so what you gonna do next? I mean, and it won't start. Like on these Altimas, this is like, for instance, there was an Altima the other day. It was a Nissan Maxima that Amber and me worked on last semester. And we did put a starter on it, and when she spun it over, it spun, and finally it started up. And then I said, pull the codes on this thing. So she pulled the code, and the front cam sensor was dead as a hammer. And so we put another cam sensor in, and it just breathed on the key, and it's running. You know what I mean? Cam sensors are weird, particularly on those those Altimas. If you unplug the cam sensor on an Altima, it may start and it may not. You know what I mean? If you unplug it, it may start. That don't necessarily mean the cam sensor is bad, because it won't start every time with the cam sensor unplugged. It just depends on whether I think it's looking at a wild card, just timing everything without the cam sensor, and if it happens to land on the right, formula, it fires up. I'm not sure how its algorithm's typed. But I will tell you this, I was called up there to the parts store when Brett was up there, and I says, what do you get for a cam sensor for this Altima here, like an 03 model? And he says, I got one $16, something like that. I said, well, throw me one of those cam sensors, I'm just gonna try something. And so when I put it on there, I still had my scope hooked up, the pattern was lined up, and it fired up. And I didn't even know a Hall effect switch could give a pattern that was out of time, but that one did. Strangest thing. And when I put that on there, they didn't have any more problems with that. It was just crazy as all get out. Another thing, like if you're, we used to work on, cam and crank sensors are pretty wacky anyway. There's another one I'll talk about a little bit later that's cam and crank sensor related, probably before the end of the semester. But always think about your cam and crank sensor, but at the same time, look at your basic stuff first. And I always like to look at the scope, and sometimes you got to take it with a grain of salt, because sometimes a bad sensor can cause the scope to be out of time, like on that Altima. Doesn't happen a lot, but you got to be ready for that kind of thing, because if you're not ready for it, you may wind up going way off around Robin Hood's barn. And this whole thing's about learning how to fix stuff. If you learn how to figure out what's wrong, so you'll know what to fix. Right? Okay. Questions or comments? Nobody went to sleep. A pretty good story. Would you like to be involved with this story? This story here. Was that a pretty good story or what? You're a connoisseur of my stories. You've heard lots of them, right? Yeah. All right. You've heard a ton of my stories and all, and the people on YouTube have too. And all you people watching on YouTube, I really appreciate you giving my channel so much exposure. And that is going to wind us up today, so we can pull the doors down and go to lunch. But we will be coming back at 1. Don't bail out of here and go anywhere, because we're going to work this afternoon. We got a vehicle inspection we got to do about 3 o'clock.